Can you hear me? Oh, yes. Okay. My apologies. I don't think you could hear me before. I had to do a little bit of technical stuff. But it appears that the mic is now working. Hooray! So brilliant to see so many of you here already, waiting patiently. Thank you so much for your patience there. So today we're going to be talking about fractions a little bit more. We're going to be talking about how to compare fractions, and we're going to be talking about different kinds of fractions that you might need to know about. So let's get started then. So a little bit of a recap of something we thought a little bit about last time. So equivalent fractions are the same in a way. They're the same amount of the whole, okay? For example, here we've got a half of a square here, which means that I've cut it into two equal pieces and I've shaded one of them in. So one half is shaded. And you can see that this also looks like a half, right? It's just that we've cut the whole square into four equal pieces this time, and two of them are shaded. So here we've got one half, and here we have 2/4, and they're the same as each other. Okay, once we have our fractions in the same sized pieces, so we could say that these quarters, they're both quarters, aren't they? So we're thinking of these both in quarters. Once we have that, the same kind of fraction, we can compare them a lot more easily. So I could think of this as 3/4, and I could think of this as 2/4. And then even without drawing a picture, I know that this is bigger than this because this is 3/4 and this is 2. Okay, so once we have the same number at the bottom of our fraction, we can compare them really easily just by looking at the top numbers. So that's what we're going to be having a go at doing today. And I'll also explain how you can do this with a calculator as well. So if you were asked which fraction is the biggest of each of these pairs, what would you think? Well, it's quite difficult to say because this is 17/20ths and this is 4/5. And I mean, a fifth is much bigger than a 20th, right? Interestingly, as the number gets smaller on the bottom, one of those type of fraction gets bigger because it's one piece out of 5 in the whole. A fifth of a pizza would be much bigger than a 20th, right? Because a 20th is only one piece out of 20. You're having to share with lots more people. Hey, hi everybody who's saying hello in the chat. It's lovely to see you all. Brilliant. So, if I want to compare these, it might be a good idea to turn them both into 20ths. Yeah? I always like to look at the smaller number on the bottom of my fraction whenever I'm doing any making the bottom numbers the same, which we'll talk more about next week as well. And I think, can I turn that 5, this smaller number, into a 20 easily by timesing it by something? And actually, I can. I could times it by 4, couldn't I? And that would get me straight into 20ths. As long as we do the same to the top, that's absolutely fine. So I can make an equivalent fraction here like we did last week. 5 times 4, that's 20. 4 times 4, that's 16. So that tells me that 16/20ths is exactly the same as 4/5. So which is bigger, 17/20ths or 4/5? 17/20ths must be the biggest, right? Because 17/20ths is going to be more than 16/20ths. And that's all I mean by comparing fractions. I know some of you were saying, oh, I don't get it. I'm not sure what to do. All we're doing is we're thinking about which one's the biggest, which one's the smallest. And it's much easier to do that when we have the same bottom number in our fractions. It's much easier to compare them. Let's try the next one. 5/14 and 3/7. Which one's the biggest? Well, it's quite hard to know, but one method we can use is I can see that I can turn 7 into a 14 by timesing it by 2. That would mean I have to times the top number by 2 as well. The reason we do this, it's a bit like we're cutting the slices into more pieces, right? So I'm cutting my fraction into, instead of 7 pieces, I'm cutting each of those pieces in half. So I'm going to end up with 14 pieces. But that means that if 3 pieces were shaded in before, each of those were cut in half. So now there are 6 pieces shaded in out of 14. Okay? And that's how I get 16/20ths and 6/14ths. If you're not sure about this, it could also be good to look at what we did last week. Again, as a little bit of a recap, because I explained a little bit more what we were doing when we were making equivalent fractions, and we visualized it a little bit more. So that could be something to have another look at as well. What about this one? 5/12ths and 5/6ths, which is the biggest? There's a different way we can do this as well, but I'm going to start with the way that we have been doing this so far, which is always a good backup option. So to turn a 6 into a 12, I would times it by 2. And if any of you have any answers for these, do feel free to put them in the chat. It'd be great to know how you're getting on. So 6 times 2 gives me 12. And 5 times 2 gives me 10. That tells me that 5/6 is exactly the same as 10/12. They're the same thing. They're the same amount of the whole. So the rule is, whatever you times or divide the top number by, do the same thing to the bottom, and you get an equivalent fraction that's exactly the same, has exactly the same amount of the whole. So now I can see a bit more easily. This is 5/12. This is 10/12. Gosh, this is way bigger. And notice, I could also work that out by looking at the bottom numbers and thinking, okay, is a 6th bigger or smaller than a 12th? And this is where you have to think really carefully, because a 6th is 1 piece out of 6, isn't it? So 1 piece out of 6 equal pieces. So a 6th is going to be quite big compared to a 12th, which is 1 piece out of 12. Let's do a few more, and I bet you can finish some of these off yourselves. Oh, yeah, all we're doing is timesing them. That's all. We're timesing. As long as we times the top and the bottom by the same thing, it's absolutely fine. We can do that, and it makes an equivalent fraction. What about this, though? This is a little bit trickier because I can't think of anything that I would times a 3 by to turn it into a 4. And that's always my go-to approach. I always think about that first because it's nice if we can leave one fraction as it is and just change the other, right? But we can't do that in this case. But this is one thing we can do. What I'm going to do is I'm going to times the 2 bottom numbers together. 3 times 4, which is 12. I'm going to turn both of my fractions into 12ths, all right? So what did I times the 3 by to turn it into 12? I times it by 4, didn't I? You just saw me do that. So that means I need to times the 2 by 4 as well. That's going to give me 8/12. What did I times the 4 by to turn it into a 3? To turn it into a 12? I times it by a 3. 4 times 3. So I need to times the 3 by 3 as well. So that gives me 9/12. Aha! Aha! So this is bigger than this. And that was quite hard to work out, actually. I think I'd have struggled a bit if I hadn't used my equivalent fractions. Really, really good comment in the comments here. You can simplify 16 16/20ths. You can simplify these. Absolutely. What we're doing is actually the opposite of simplifying. We're making equivalent fractions where the numbers are bigger. Simplifying is going in the other direction. But they're both different ways of finding equivalent fractions. You can do either. Really good point there. Fantastic. So I could absolutely simplify these again. Let's try a couple more and then we'll think about something else. Ooh, okay, 5 and 3. Can I turn a 3 into 5 by multiplying it by something? Not easily, no. So I'm going to use my trick. I'm going to do 5 times 3 to get a new bottom number for both of my fractions. And the reason that works really well is because when you times the numbers together, you found a number that you can easily get to from both of the numbers because we just did it, didn't we? 5 times 3 means that we've times this 5 by 3 to get 15. So we times the 2 by 3. I do apologise about the writing. It's because I've got so many things for the stream on my laptop. It's slowing down my pen. I'm going to have to see what I can do about that. And 3, I just times by 5, didn't I? And that also made 15. So that's quite a nice technique for finding a number that you can get to easily from both of two other numbers. So I'm seeing some really, really good ideas here in the chat, and some, yeah, really good effort, everybody. Okay, so 10/15 and 6/15, which one's the biggest? It's going to be this one, isn't it? 2/3. Yeah, great idea here. For this next one, we could multiply this by 2, couldn't we? Because to turn the 5 into a 10, hey, well noticed. I can times it by 2. It just means I have to times the top number by 2 as well, but that's okay. We can do that. 3 times 2, that's 6. 5 times 2, that's 10. And that tells me this is the same as 6/10. We're doing the opposite of simplifying. We're making an equivalent fraction where the numbers are bigger. But that's really helpful both when we're comparing fractions, and next week we're going to be talking about adding and taking away fractions. It's important for that as well. Fantastic. All right, I bet you could have a go at that last one as well. Brilliant, well done. Okay, how do we do this with a calculator? Well, we can put any fraction into any calculator by dividing the top number by the bottom number. Okay, so what I would need to do is for this one, I type into my calculator 3 divided by 5. That's all I need to do. Even if your calculator is just a normal calculator, without any special fraction buttons, you can put your fraction in by dividing. Because actually, fractions and divisions, you'll get tired of me saying, are actually the same thing, just in a slightly different way. And we'll talk about that in the future. So if I put that into my calculator, on a standard normal calculator, I'm going to get an answer of 0.6. Okay, my answer is a decimal. What about the other one? 4/7, 4 divided by 7. That's what I'm putting into my calculator. And then the answer I get is going to be something like 0.5714, and it goes on and on. So which one's biggest? So this is where we need to have a think about comparing decimals. And we would start by looking at the first digit, wouldn't we? 6 is bigger than 5. So 0.6 is bigger. So that means 3/5 is bigger. So that's how you can compare fractions with a calculator. And it would be great for me to know actually whether you want me to talk a bit more about comparing numbers and comparing decimals as well, because that could be quite useful for some of you. So let me know if you'd like me to do that. So let's have a think now about different kinds of fractions. We might have to finish this off a bit next time. We'll see how it goes. So today, so far, and last week, we've been talking about fractions that are smaller than a whole. right? Smaller than the whole pizza or the whole circle or the whole square, like 3/4. Sometimes, though, fractions are bigger than a whole. Some of you might know that these are called improper fractions, but they're just a different type of fraction, aren't they? They have a bigger number on the top than on the bottom. So 11/4 would look like this. It's like I've got one pizza that's cut into four. I've got a second pizza that's cut into four. That's 8/4. And then I've got three more. So 11/4 in total. But instead of thinking about it as 11 slices, 11/4, instead I could think of it as two whole pizzas and 3/4 of a pizza. Yeah? So once fractions are bigger than one whole, we can express them either as fractions or as something called mixed numbers, which I'm sure you've seen around a lot. When you say 2 and 3/4, that's a mixed number. You're saying there's two wholes and there's 3/4 of one as well. Yeah, 3/4 extra. So it's really good if we know how to convert between um, improper fractions, these fractions with a bigger number on the top, and mixed numbers like this. It's also really good to realise, just as a bit of extra, that if you ever see the same number on the top and bottom of your fraction, that means one whole, doesn't it? So 4/4, if I have 4/4 of a pizza, that's one pizza, that's a whole. If I have 3/3, that's a whole as well. If I have 2/2, yeah, that's still the whole pizza, isn't it? All this is saying is the whole is cut into four pieces and I've got all of them. So whenever you've got the same number on the top and the bottom, you can simplify that to a whole. It's just one. All right? Fantastic. So let's have a go at turning some mixed numbers into fractions. So in this example from earlier, we've got two whole pizzas and then we've got 3/4 of a pizza. So you'll notice that each whole is made up of four pieces. We've got two wholes, which is here, and we know that the wholes are in four pieces because of this number down here. Okay, so one thing we can do is 2 times 4, so that's 8, to tell us how many slices are in the whole pizzas. 2 times 4, because it's two lots of 4/4, isn't it? Two lots of 4. So that's 8. I'm going to write that down so I don't forget it. And then we've got another 3/4 here, and that's on the top. When we look at the number, we can see the 3 on the top. That's telling us about this 3/4 here. So I need to add 3 on there. 8 plus 3, that's 11. So that's how we make a new top number for our fraction. Then all we need to do is put that top number over the old bottom number. The pizza's still in quarters. We're still going to think about quarters. It's just now we've included these 8/4 as well as this 3/4. So altogether we have 11/4. Hopefully that makes sense. So if you wanted to start with, you could draw your own picture. Maybe you could draw some circles, or if you prefer, you could draw some squares. Got a tickle in my throat, so apologies if I'm sounding a bit strange. Okay, 1.5. Well, that's like 1, which we could think of in halves. It's 2 halves. And then another half. So there's my half, and here's my 1 whole, which is 2 halves, isn't it? So 1.5 is going to be one lot of 2, one lot of 2 halves, that's 2, plus one more half. 2 plus 1, that's 3. That tells me how many halves we've got in total. Then I need to put that 3 over the 2 to show that they're still halves. And I always want to be working in this fraction, whatever's at the bottom here. I could actually split these wholes into any fraction. As you know, we could cut it into more pieces if we wanted, but because we've got halves here, we're going to think of them in halves so that we can turn everything into halves. And for this first question, I turned everything into quarters. Make sense? Oh, brilliant. So let's have a go. And you can go through these again and draw some pictures if that's helpful. I know we're all at different stages with how much of this practice we've done. I'm going to think of just the number, okay? But I'll explain what I'm doing. So first of all, I'm going to do 4 times 3. That's 12. That tells me that in these 4 holes, there are 12 little thirds. Okay, so 12. I'm going to write that down here. But then I've got 2 more thirds, haven't I, at the top here? So I'm going to add those 2 on. And then I'm going to have to put it over a 3 at the end to show that it's still thirds. So 12 add 2, that's 14. So that tells me that I have 14 thirds. Make sense? Let's do one more. So here we've got 3 and 1/9. So if I do 3 times 9, that tells me that in these 3 holes, I have 3 times 9, 27. 27 little slices, 27 little ninths in the 3 holes. I can kind of picture that. I can picture 3 circles, each cut into 9, so there are 27 slices there in total. Then I need to add this one on to make 28. So in total, I've got 28 ninths. Let's do a couple more. Let's finish these ones off and then we'll do the other direction next time with a little bit of a recap, I think. Wow, fantastic. So for this one, we're turning this all into fifths, aren't we? So 5 times 5 tells me that in that 5 holes, there are 25 fifths. And then I have to add 2 more on. That gives me 27 fifths in total. And then this 2, I need to turn into sevenths for 2 and 4 sevenths. In this 2, there are 2 times 7, 14. 14 little sevenths in this 2 holes. And then I'm going to add on the 4, this 4 sevenths that was already there. So 14 add 4, that's 18, isn't it? So that gives me 18 sevenths. Fantastic, brilliant. And some really, really good comments in the chat there. I think everybody's done really, really well with that. Fantastic. So we will finish this off with our fractions into mixed numbers next time. So perhaps do a little bit of practice of changing your mixed numbers into fractions. And we have some extra practice questions for you to do if you would like to. And I've also linked some extra practice from different places over on Facebook and on YouTube. So I will look forward to hearing how that goes, and I will see you next time. Well done, everybody. Okay, so for those of you still here,